So this first look at our central nervous system is going to look at the spinal cord. So the spinal cord is going to function in conducting information up and down the body. So when we receive information from our hands and we want to move our arm in response, that information has to go all the way to the spinal cord at the level of the arm, all the way up to the brain, get integrated, and then come all the way back down to the arm to move a muscle. So along with the fact that these are nerves and our nerves function in communication, this communication has to kind of go up and down the body. You can think of it like an elevator of information. The spinal cord does do some integration, so it's not just moving things around. When we have reflexes, which are quick voluntary reactions. So imagine when you put your hand on a stove and you don't wait for that information to go up to your brain while your hand is burning, you immediately pull it away. So all of us have reflexes that get integrated in the spinal cord. And this means that the information doesn't have to go as far, and it can happen very quickly. It's also involuntary. You don't have any control over that. So when you pull your hand away from a stove, it's like a knee jerk. You're not doing that because you think it's a good idea. Our spinal cord is also involved in locomotion, so central pattern generators. These are types of reflexes where repetitive motions of walking actually generate the gait that we use. So this is a really cool video. So it's a decerebrate cat. The link is also posted in D2L under study materials. And you can see this cat's brain has been severed from its spinal cord. That's what decerebrate means. And so the cat is still able to walk and run, even though it's not sending that information to the brain. It's the body and the spinal cord that determine your patterns of movement. So here we can kind of see the posterior or dorsal view of the spinal cord. So they've removed all of the vertebral arches, and you can see that there are two enlargements. There's a cervical enlargement and there is a lumbar enlargement where so these are regions where the spinal cord is actually thicker. There are 31 pairs of spinal nerves starting from the top, coming all the way down to the lumbar and sacral region. You can see that the spinal cord actually kind of tapers down here and then stops at about the first lumbar vertebra. This is because the vertebra column actually grows faster than the spinal cord itself. So at about the first lumbar, it necks down into what's called the medullary cone. And then below that, we've got the cauda equina, which actually means horsetail. And you can see it kind of looks like a horse's tail of nerves coming down here and then exiting the vertebral column at the lumbar and sacral regions. The spinal cord is surrounded by 3 membranes, and we call these membranes meninges. And these are going to be the same meninges that surround the brain because they're actually continuous with these meninges. So going from superficial to deep, we're going to start with the dura mater, and dura mater literally means tough mother. So this is a very tough, thick sheath out here on the outside, and this is going to be kind of a looser sleeve, kind of like when you put on a rubber kitchen glove and it doesn't suck tight to your skin. Beneath the dura mater is the arachnoid mater, and so this is about 5 to 6 layers of cells. It adheres to the inside of the dura mater, but there is a space between the arachnoid mater and then the deepest layer, which is called the pia mater. The pia mater is here in pink, and this is going to adhere tightly to the actual spinal cord. It even follows the contour, so you can see that it's kind of going over and under with the spinal cord, and it goes deep down into these sulci. Here we can see a cross section. So this is dorsal, this would be the vertebral spine, and then anterior. So basically what we've done is we've cut between these two vertebrae, and we're looking at the vertebral column inside. So here's my vertebral arch, and all of this is the vertebral foramen, only now instead of being empty, we're looking at the actual spinal column. I know that we're looking at the cervical spine right now because we can see these transverse foramen. There's some fat in this epidural space. So epi means above, and dural is talking about the dura mater. So the epidural is right here between the bone and the dural space. This is where you would get an epidural injection between the two vertebrae into this space in childbirth, when you get an epidural to help relieve the feeling during labor. So here's the dura mater, that's the outer wrapping. And then you can see the arachnoid mater is this blue layer here. It has some strings that connect between it and the pia mater. And arachnoid, think spider. Spiders are arachnids. And so some of these fibers actually kind of look a little bit like a spider web. So we have a space here, which is called the subarachnoid space. Sub means below. So this makes sense, it's below the arachnoid mater. And then the pink is the pia mater here. So the spinal cord, the actual nerve tracks, are these kind of light brown and dark brown matters here. And we can see the color difference between the gray matter and the white matter. So the gray matter is this darker shaped H here. So this is gray matter. And it's gray because it's got... So this gray matter is made up of the dorsal horn, which is this region, and the ventral horn, which is down here. And this area in between that goes across from left to right is called the gray commissure. Here we have the central canal. That central canal is going to be continuous all the way to the brain with the ventricles of the brain. All of this lighter matter out here is going to be the white matter. And it does have myelin. So these are going to be faster nerve impulses that are conductive through the myelin. As we move out, we can see that there are roots coming off of the dorsal and the ventral. So anterior and ventral are the same, posterior and dorsal are the same. These are going to get the names the dorsal root and the ventral root. These are going to come together. The dorsal root also has a ganglion here. A ganglion is where all of the cell bodies are. So this is a collection of cell bodies, and that's why it looks thicker here. The ventral root doesn't have that ganglion. So it's appropriate to call this the dorsal root or the posterior root. Those are both the same. Same with this side. You can call it the ventral root or the anterior root. I'm typically going to use dorsal and ventral. These are going to merge together. So these are wrapped around with this dura mater. So this area where the dorsal and the ventral root are together is where we call it the spinal nerve. So you can see at this point it has left the vertebral cavity and is now exiting the vertebra. And then this is going to go ahead and split again into a dorsal and a ventral section. So take a moment and reflect on the 3 meninges that surround the central nervous system.